Hello, my name is Kyle Lyon, pre-sales engineer here at Solutions PT, and in today's episode of Tech Bytes, we're going to be going over the different analytical capabilities contained inside of AVEVA Insight, which is our cloud-based asset performance and data visualization platform. So we generally have about four main types of analytics that we use. And which ones are best placed to be used generally depend on a variety of things, such as your size of your application, your industry that you're in, the size that you are, the investment capability that you have. So I'll introduce each one here and just go over briefly sort of what they do and where they're mostly used. So starting at the bottom of this circle here, we've got automated analytics. And what this is unsupervised machine learning, and it's included with AVEVA Insight as standard. What happens with this is when you start uploading data into Insight, it'll automatically scan your data on a tag by tag basis, and it'll establish a baseline model for the behavior of that tag without any configuration necessary on your end. It will then post anomalies for these tags into the newsfeed. This can include things such as indications of a tag flatlining, being higher or lower than usual, and any deviations from historical patterns. This helps operators and technicians understand if changes need to be made to bring these items back in line with expected normal operating values. As I mentioned, these anomalies are shown in the news feed where they can be viewed and interacted with. You can provide feedback for the algorithm to let it know which types of anomalies it's detecting are useful and which ones aren't necessarily. And you also have access to a little bit of a description of what the actual anomaly is beyond just the visual context that you're given. So where we generally see this used, obviously, is to provide a little bit of indication to users, maybe through the mobile app, maybe through embedding Insight within your SCADA, your Viva OMI, for example, to just quickly provide a detection of any anomalies like that. Second up, moving up a level, we've got the condition-based rules. And what this does is it allows for the configuration of rules that will be triggered and alerted on when a certain condition is met. So condition-based rules are generally best used to monitor known limit conditions in assets and prevent non-desired operational conditions and downtime through that. You use a very simple wizard configuration to identify the inputs that make up the condition and the conditions that those are. So for example, a tag being higher than a certain value, and you can combine these conditions within the same actual rule, so you can alert when all of these conditions are met or just when one of them is met. An example of this could be a pump. You could take the inlet temperature, inlet pressure, flow rates, as well as the outlet temperature, pressure, and calculate maybe the differential pressure, or delta P, across that pump. Using this example, maybe we detect a change in that delta P that we've identified as being indicative of an imminent leak failure condition for that pump. These condition-based alerts can be configured to automatically send notifications to maintenance staff to alert them of this prior to the actual problem occurring. Beyond this, though, you can also link to the likes of your CMMS system and trigger work orders straight from your ERP. Also included within the condition is the option to provide prescriptive actions along with the alert. And what these are step-by-step instructions that you define for how to address this particular failure that can be sent with the notification to your maintenance engineers' mobile phones, wearable devices, tablets, etc. And this provides them with the steps they need to help them know how to remediate that problem. For the third one, we have guided analytics. The idea with guided analytics is to look towards a more predictive maintenance strategy by providing early warnings of performance degradation that may not initially be known, like we knew for the condition-based rules. Where condition-based rules are about identifying known conditions and setting rules based on them, with guided analytics, we help you find out that information and those conditions. Using supervised machine learning, the system can learn what the normal operation conditions are, for example, high loading, low loading, ambient conditions. And we can start to develop models based on those different conditions. Guided analytics is particularly effective for process anomaly detection in hybrid industries. It can be used for most generic assets, and it's, again, easy to set up with another built-in wizard interface that walks the user through the configuration of detection of this data. You define the tags that you're looking at, the time period that you want to analyze. Obviously, the more time, the better. And you can also filter this data to provide areas where maybe you've got no production, slow production, you don't want to include it as an example of good practice, that's completely fine. We can strip those out so that they're not catered into the model. Once you've set this up, you've created a model within the system, which then feeds back how current operations are doing in comparison to that previously understood good operation model. It'll give you a score of deviation from 0, which is perfectly tracing that model, to 100, which is wildly deviating from the model. And it will alert you when that condition reaches about an 85 threshold, but obviously we can combine this with the condition-based rules because this actual deviation score becomes a tag within Insight that we can alert on separately. And finally, we have advanced analytics. So advanced analytics is for the most strategic, the most critical assets in your facility. Think high-cost items such as compressors. This tool provides a means of creating more in-depth models for not only predictive maintenance, but other very specific use cases, such as predictive quality, energy consumption per product per line, remaining useful life for that piece of equipment until it reaches a certain failure state, and things like that. So we're solving for a more specific problem. And in doing so, we're leveraging a specific approach and liaising with our expert engineers and subject matter experts with the tools included within the advanced analytics package to create custom tailored models that pick out exactly what we need to determine these very specific problems. We're planning to do separate Tech Bytes for each of these analytics packages, where we talk about them a bit more in depth and show you how to configure them in the future. This episode is more just intended to provide you with a broad overview of the analytics capabilities inside of AVEVA Insight. So hopefully you've walked away from this knowing a little bit more about what options you've got available. Thank you for watching, and obviously if you have any questions or would like to get in touch with us about anything AVEVA Insight related, or even in relation to the rest of the portfolio, please do feel free to get in touch with us in the links below.